All right, we're going to do one that's a little more involved, relative motion. So this is a plane. The plane is flying east at 60 meters per second. So the plane can go 60 meters per second. Okay, and it wants to go east. But there's a wind from the northeast. So the northeast at 10 meters per second. So instead of it going exactly perpendicular or exactly head on, it's going at an angle to him. The plane needs to travel 75 kilometers. So the plane wants to go 75 kilometers. Again, we need to figure out what angle the plane needs to go, what direction it should fly, and how long it'll take to get there. All right, so what we have to do is we set up our triangle of velocities. So we have that the plane is going to go this way, but the wind is coming back this way. That's not very accurate. Let me draw that bigger too. So the plane is going to go like that. Wind is going this way. And this is the velocity of the plane with respect to the air. So this is the 60 meters per second up here. This is the wind at 10 meters per second. What we need to do is figure out this angle. Now the biggest difference between this and the other ones is this is not a right triangle anymore. And since it's not a right triangle, I can't use my trig functions. So all of a sudden it makes it much more difficult. Not real hard, but we have to figure out how to convert it so we can use our trig functions. So what we're going to do is we're just going to extend this and make it into a right triangle. But what I need to know is I need to know what this side is over here. I need to know this side on the triangle. Then if I know that side, and I know this side, the hypotenuse, which I do know, I can figure out what that angle is. I do know this is from the northeast, which means that these are 45 degrees. From the northeast means it's a sub-cardinal point, so it's exactly 45 degrees. So now I have a 45-45 triangle with a 10 meters per second on the hypotenuse. I can figure out what that side is. Or I can say this, if I'm looking at this angle right here, I can say that the sine of 45 degrees is equal to x over 10, or x is equal to 10 sine of 45, or x is equal to 7.07 meters per second. So this side here has to be 7.07 meters per second. So does this side because it's a right triangle. I mean, it's a isosceles triangle. The sides are equal. It's 45, 45, 90 triangle. Okay, so this part right here is 7.07. This is 7.07. So I can figure out what angle I need to fly now by saying, oh, this is theta. The sine of theta is equal to opposite. Well, the opposite is here, 7.07 over 60. And I get that the angle there is 6.77 degrees north of east, right? North of east. Or you fly a heading of 90 minus that, and so your heading would be 83.23 degrees. All right. But now we want to figure out how long it's going to take him to fly 75 kilometers. To do that, we have to know this velocity, because this is the actual velocity with respect to the ground is right there. Not the whole side, just this part right here. But I do know that this much is 7.07, so if I get the whole side, I can just subtract out that side. So if you look at this as a big triangle, right? Back to our full triangle again. I know this angle down, I know this side, I can figure out what this side is. So I'm going to use cosine and say cosine of 6.77 degrees is equal to the adjacent, which we'll call A, which is the whole side, okay? Call that A, divided by 60. And when I do that, I'm going to get A is equal to 60 cosine of 6.77. And when you calculate that, you get get? .58 meters per second. And then, so that's the whole side, but my velocity with respect to the ground is going to be 59.58 minus 7.07. And so you subtract that off of there, and you get that the ground speed is 52.5 meters per second. Now we know our distance is 75 kilometers. So we're going on a constant velocity, so distance is velocity times time, where the time is the distance over velocity. Remember, we have to convert this, so this is 75,000 meters divided by 52.5, and you get the amount of time that it takes is 1,428.6 seconds. Or we do that in minutes, divide by 60, you get 23.8 minutes. All right, so here's the answers. Notice that was a little bit trickier than the ones we used to because this triangle that we used to solve everything was a little more complicated because that angle of the wind was not exactly perpendicular.